Hello everyone. This is about digital electronics and microprocessors. And in this video, the question paper pattern is being discussed based on our previous question papers. And I have prepared the slides based on previous papers and all unit syllabus separately. So this is the syllabus for Unit 1. In Unit 1, the syllabus included number systems, code conversion, Boolean algebra, logic gate, truth tables, universal gates, simplification of Boolean functions, SOP and POS method, simplification of Boolean functions using K-map, and signed and unsigned binary numbers. So in first unit, these 8 questions were asked for 2 marks. And this first question is realize OR gate using NAND gate. So NAND gate is a universal gate and you have to ask to draw only OR gate using NAND gate. So when you draw OR gate using NAND gate, you require 3 NAND gates. The second question asks state the limitations of K-map. So the limitations of K-map is that the K-map is very easy up to 4 variable and we can also extend K-map up to 5 variable. But beyond 5, the K-map is very difficult and complex. So for that complexity or more number of variables, the another method to simplify the Boolean function is discussed as Cohen-McCluskey method or tabular methods. So tabular method is not in your syllabus, but tabular method is the alternative of K-map for higher order of variables or higher number of variables. The third question is asked what are called don't care conditions in digital logic. So don't care conditions are the skipped input combination in a truth table. Those can be used just to simplify or minimize the Boolean expression, but we don't bother about the output of that input combinations. The fourth question is asked which gates are called as universal gates. What are its advantages? So NAND gate and NOR gates are your universal gates, and you can implement total logic gates. We have 7. So if NAND gate you are using NAND gate as a universal gate, then you have to implement 6 remaining gates using NAND gates. So the universal property of universal property of universal gates is that you can implement rest of the gates using only single gate, either using NAND gate or NOR gate. The fifth question is asked what is unsigned binary number? So unsigned binary number is the binary number where no bit is reserved for the sign purpose. Means in binary number all bits represents magnitude only. And the sixth one question about number conversion. So you have to give in one decimal number and you have to convert into hexadecimal. So I have to write this answer. So you have to follow the procedure to convert this number. In next class, I will discuss in brief how you can convert this number. The seventh question is also regarding number conversion from binary to decimal. The eighth question asks state the different ways for representing the signed binary number. So for signed binary number, you have 3 ways to represent. The first one is sign magnitude form, and the second one is ones complement form. Third one is two's complement form. So these 8 questions asked for 2 marks from unit 1. So based on the pattern of these 8 questions, your important topics are like logic gates, number system, Boolean algebra, and K-map. So if you want to skip few points in unit 1, so you can skip, but these 4 points or these 4 topics are very important for unit 1. Now in this slide, I have framed question which have asked for the higher marks, means 4 to 10. So the first question related to number conversion, means decimal to binary, and this question asked for the 5 marks, and decimal to binary and octal number system. So this is very easy question regarding number system. The second question asked for the implement the Boolean function with NAND gate. So first of all, the given Boolean function you have to minimize using K-map. And after minimization, you got your minimized expression. and then minimize expression you have to implement using NAND gates, because while proving the universal properties of NAND gates, what you will do to implement the OR expression by NAND gate, you have to implement AND expression by NAND gate. So whatever expression you got minimizing this Boolean function, you have to implement this using NAND gate. The third question related to simplify Boolean function using K-map technique. The fourth one is also the simplification of Boolean function using K-map. But in the third one, it is asked for the SOP method, and the second one means fourth one, you have asked to minimize the Boolean function using POS method. In POS method, we target the combination of zeros, while in SOP we target the group of ones. The fifth question is also regarding number system, hexadecimal to decimal, binary, and octal. The sixth question, simplify the expression, and at this time this is not mentioned, you have to simplify this expression using K-map or Boolean algebra. So because it is not clearly mentioned, so you have both options. You can also simplify this expression using K-map. You can also simplify the same expression using Boolean algebra rules. In the seventh question, the number conversion asked for 10 marks, means just dividing 10 marks into 2. So 5 conversion is there. So this is one way to ask the number conversion for 10 marks. The eighth question is express the following function in standard SOP form, and means two Boolean function given and you have to represent in standard SOP form. What is the standard SOP form? In standard SOP form, you have to first convert this expression into canonical form. Then using canonical form, you have to write the index of minterm or max terms. The ninth question is also asked for number conversion for 10 marks. And the 10th question is implement the inverter gate, OR gate, AND gate using NAND gate and NOR gate. So you know NAND gate and NOR gate both are universal gate. So this is very easy question, because only inverter means NOT gate. Only NOT gate, OR gate, AND gate you have to implement using NAND gate or NOR gate. Little bit difficult, you feel difficulty to implement the XOR gate and XNOR gate. But here only basic logic gates asked to implement using universal logic gates. So in unit 1, these questions ask for 4 to 10 marks. And unit 1, I have framed this one slide for number conversion. So you can categorize all number conversion problems to 4 types. Decimal to others, where integer conversion follows division rule and fraction conversion follows multiplication rule. The second category is others to decimal. And in this case, we have to expand the integer part over positive powers of radix, and for fraction part expand over negative powers of radix. The third category is binary to other radix, which can be represented as power of 2, like octal and hexadecimal. The fourth category is other radix to binary. So the next topic is logic gates. So basically you have total 7 logic gates, not OR, AND, NAND, NOR, XOR, XNOR. And NAND and NOR gate are universal gate. So whenever the universal property is asked for these 2 gates, you have to implement rest of the 6 gate. Those who are comfortable up to this point, they can also extra prepare like half adder and full adder implementation using universal gates. But this is not for all. Those who have prepared the upper part, then they can go for the last 2 one. This is little bit complex, but may be asked. I have taken this one general example to convert decimal to others. So here we are converting our decimal number into octal number. So while converting 88, the integer part of number, we follow the division rule. So 88 divided by 8, and every time we have to notice the quotient and remainder, and quotient again divided by the 8. So after following this approach, the integer part converted into 130 and fractional part converted into 275. This is not always necessary. Your fractional part conversion terminates. Sometimes it is unterminated form. So you have to write up to three places or four places. Either this thing is mentioned in the question. You have to calculate this or you have to convert this number up to four places of decimal. And the second category number conversion, octal to decimal. This comes under the others to decimal. In this case, you have to expand the number over the power of radix. So the red color I have shown for the integer conversion and green color for the fractional conversion. So you have to follow this approach for other number system to decimal number system. The third category is binary to octal. So octal base is 8 and 8 can be represented as 2 to the power 3. So we have to combine 3 bit at a time. For integer part, left to decimal point or radix point, and for fractional part, right to radix point. So this is the way to convert the number. So you have to practice well for this thing because this topic cannot be ignored by any of the paper setter. So you will 100% face some conversion problems and you have to know all this very well. The next topic is in unit 1 is signed and unsigned binary number. So I have written the range of unsigned binary number and signed binary number. So unsigned binary number range is 0 to the power n minus 1. And in the lower slide, I have written the range for signed magnitude form, 1's complement form and 2's complement form. The extra topic you want to prepare this gray code to binary and binary to gray code conversion. This is also very important topic or important question may be asked from this topic because no question have asked yet up to now, means last 2 or 3 4 previous papers this question is not asked. So maybe as a new question you might face this question, gray code to binary or binary to gray code conversion. The next thing in unit 1 is Boolean algebra rules and K-map. So you have to know this all Boolean algebra rules. Sometimes the question is asked and strictly follows. You have to follow the Boolean algebra rules to minimize the given Boolean function. Because sometimes it is strictly mentioned that you have to minimize, you have to simplify this Boolean function using Boolean algebra rules. Then no scope is there for K-map. If there is no mention like Boolean algebra came up, then you have option. So you also know this Boolean algebra rules to simplify the Boolean functions. And after this Boolean algebra rules, you have another K-map rules. So in K-map rules, you have single one, pair, quad, octet, and sometimes all ones is there. Don't care condition is also very important concept in K-map. And while minimizing the expression using K-map, you should be also aware about SOP and POS method. In SOP, we target the group of ones. In POS, we target group of zeros. The extra topic in this case, you must know about the implicants, prime implicants, essential prime implicants, and redundant implicants. So in each, when you are solving the SOP using K-map, then each one is called implicants. If you are solving POS using K-map, then each zero is called implicants. Prime implicants are the terms which you got in minimized expression. The essential prime implicants, whatever prime implicant or minterm you got after making pair or quad or octet, then if some pair quad octet has at least one which is not covered by any other group, then it is called essential prime implicants. And sometimes it is also possible student might take two pairs, whether it is possible to make a quad, but they use two pairs. And in this case, you got some redundant terms, and that redundant terms is called redundant implicants. So in unit 2, you have syllabus combination logic circuit, adders, subtractors, multiplexer, demultiplexers, encoder, decoders, programmable logic devices. So this is your unit 2 syllabus. And based on unit 2 syllabus, these 8 questions asked for the 2 marks. The first question is the PAL same as the PLA? Justify. So these two are programmable logic devices, PA and PLA. And you have to differentiate between these two. The second question is compare and contrast encoder and multiplexers. The third question is about differentiate decoder and demultiplexer. The fourth one is draw the circuit of a half adder. Fifth one is what is decoder. Sixth one is define encoder. Seventh one is what is demultiplexer. And eighth one is what is PLD, programmable logic devices. So when you observe all these 8 questions, you will find that only definitions and differences asked for 2 marks in second unit. And second unit is a combination circuits. So you must know the definition of all the combination circuits and little bit able to differentiate among those. So like 2 differences are differentiate decoder and demultiplexer and compare contrast encoder and multiplexers. So definition and differences can be asked from for 2 marks from the second two. In this second unit, for long questions, 4 to 10 marks, these questions ask like design a half subtractor circuit. Second one, design and explain the working of full adder. Third one is design 3 to 8 line decoder with necessary diagram. Fourth one is write short notes on programmable logic devices. In this fourth question, you have to explain little bit about all 3 PLDs like PROM, PLA and PAL. And I have covered in the class in a very detailed manner all these 3 PLDs. The fifth question is design and explain the working of a 4 to 1 multiplexer. The sixth one is design a priority encoder for 4-bit. So for 4 to 10 marks in unit 2, you have to be aware about the each circuitry of each combiner circuit and working. Because in all question only working or architecture may be asked. So the 10th question is write a note on high speed adder. So what is high speed adder? We have discussed many adders in the combination circuit, but high speed adder is your carry look ahead adder, because in carry look ahead adder the propagation delay is reduced very much. So because we reduce the propagation delay using carry look ahead adder, that's why it is high speed adder. So in the 10th question, carry look ahead adder is asked indirectly. The 7th question is about draw and explain the block diagram of 4-bit parallel adder. You know, 4-bit parallel adder can also be used as a 4-bit parallel subtractor. So sometimes it is also asked for the subtraction purpose. The 8th question is about implement the following function with a multiplexer. So in this case, you have to implement this Boolean function using multiplexer. And here it is not mentioned you have to take the variable A, B, C, D at data lines or any other variable. So as per your convenience, you can take A on data lines, B on data lines, C on data lines or D on data lines. So if anything is not mentioned, the always the easiest, the easy procedure to follow, you have to take the LSB at data lines and other 3 variables used as a selection lines. The 11th question is asked, explain the circuit diagram of full subtractor. So all these questions are just theoretical paragraph or theoretical construction of each topic, means each combinational circuit. So this is the very easy question is there. If you have prepared any topic, then you can easily write for 5 marks or 10 marks. The 12th question is about explain about tri-state gates in digital circuits. So tri-state gate is like a in inverter. You can the first one is buffer when you got output equal to input. The second one is inverter. The third condition is called high input impedance. So you have to go through the some other nodes for this. uh, tri-state gates. I think I have not covered this into the lectures or classes. So you have to be aware about the tri-state gates and prefer some other notes to read this topic, tri-state gates. The third one is design a half adder using NAND gates. So I have already discussed the universal properties for NAND gate, NOR gate can be implemented for basic gates or special purpose logic gates. Sometimes it is also asked for half adder, full adder, and half subtractor, full subtractor. In third unit, you have sequential logic circuits, RS, clubbed RS, D, JK, master slave, JK flip flop, T flip flop, shift registers, types of shift registers, counters, ripple counter, synchronous counter, asynchronous counter, and up down counter. So this complete unit just all about latches and flip flops and shift register and counter. So three categories is there. So let's see for 2 marks in unit 3, what are the questions? Previously in exam, these questions asked for 2 marks in third unit. What is triggering? What is the need for trigger in a flip flop? So very well known, triggering is two type, label triggered and age triggered. So you have to explain the triggering and need of triggering in flip flop and need of trigger in a flip flop. The second question is about compare asynchronous and synchronous counters. So if you compare latch and flip flop, you can also write the same thing because latches are asynchronous and flip flops are synchronous. So you preparing same difference table you can write for latch and flip flops, and also by modifying little bit you can also prepare the same table for asynchronous synchronous counter difference. The third question is distinguish between combination and sequential logic circuit. The fourth one defines shift register. Fifth one write about ripple counter. What is shift registers? Write a note on sequential logic circuit. Define up down counter. So like unit 1, in this unit also the difference and definition is asked. So few questions belong to the difference and compare, and few questions belongs to the directly. You have to define the shift register, define down counter, define sequential circuit. So all are definition and comparison. For high marks means 4 to 10. What are the question? The first question, design and explain the working of an up down ripple counter. So you have to be clear about this idea of asynchronous counter because asynchronous counter are also called ripple counter. And in up down counter, you must know this for up counter, you have to use preset signal because up counter starts from all ones and down sorry, up counter starts from all zeros. So you have to use reset signal, and down counters start from all ones. So you have to use preset signal. The second question is explain the operation of serial in parallel out shift register. So only one shift register is asked, serial in parallel out. So for serial in data, you require n clock pulses, and parallel out, you require no clock pulses there. The third question is about explain master slave JK flip flop with the need diagram. First of all, you must aware about the race around condition of JK flip flop. If you know the race around condition, then you can easily explain the working of master slave JK flip flop. Because for race around condition, using master slave, we try to avoid the input combination situation 1-1. The fourth one is explain about 4-bit synchronous up counter. So I have explained the procedure how you can design the synchronous counter. So at this time you have to design 4-bit synchronous up counter following all those steps. The fifth question is draw the circuit diagram of a clock D flip flop with NAND gates and explain its operation using truth table. Give its timing diagram. So in this case, D flip flop is asked. And you have to explain the operation and timing diagram. So taking the input combination, output and clock signal, you can easily draw the waveform, and that waveform is called timing diagram. The sixth one is called distinguish between synchronous and asynchronous counter. This time this question asked for 5 marks. Previously you have seen that this difference is asked for 2 marks, but at this time this is asked for 5 marks. So means that you have to write the difference exhaustively, means taking like 8 to 10 points, not mentioning only few points, maybe 2 3 points is sufficient to got 5 marks. So for 5 marks you have to write this question in a very explained manner. The seventh one is what is T flip flop? Explain it. So only T flip flop is asked for 5 marks. And I have told you all this flip flop following the like some 7 to 8 steps. Starting from functional table, truth table, characteristic table, all those things are there. The eighth question is what is RS flip flop? Explain working of clocked RS flip flop and convergence of flip flop. So this question are for 10 marks, and in this case you have to first of all define little bit about RS flip flop. Then you have to take the working of clocked RS flip flop and conversion of flip flop. You have to also discuss in this question especially steps to implement the conversion of flip flops, because not exact conversion is given, means nowhere is written like RS to D, RS to T, RS to JK. So in this case generally you have to define all required steps to flip flop conversion. The ninth question is with a neat block diagram and explain the operation of serial transfer between two shift registers and draw its timing diagram. So in this case you have to take the example of serial transfer. So serial transfer you can use serial in serial out data, means CISO shift register. In the fourth unit you have introduction about 8085 microprocessor and 8086 microprocessor, and functional diagram, register organization, flag register of 8086 and its functions, addressing modes, pin diagram, minimum mode, maximum mode of 8086, and interrupts of 8086. In this fourth unit, for 2 marks, these questions asked in the previous exam. What is pipeline architecture? So this is some definition like, so you have to go through some notes or you have to directly search for this pipeline architecture, and this is like one paragraph definition is there. The second one, what is the function of D flag in 8086? So for 8086 you have flag register of 16 bit and total 9 flags is defined, but here for 2 marks only one flag is asked, means D flag. So you have to write the functioning of D flag. In third question, what is the role of TF and IF? So TF is a trap flag and IF flag is instructions flag in the flag register of 8086. So means in this case, first of all, you have to know about all flags of 8086, means all 9 flags. So if this question asks for 2 marks, you have to write either one flag or 2 flag. If this question asks for 5 marks or 10 marks, then you have to explain all the flags. The fourth question asks for what is meant by software interrupt in 8086. So in 8086, I have covered one topic. In that, you have only two hardware interrupts, NMI non-maskable interrupt and INTR. So only these two interrupts are hardware interrupt in 8086. The remaining all interrupts are belong to the software category. The fifth one is what is carry flag, and carry flag is common for both 8085 and 8086. So you have to write the functioning of carry flag. The sixth question is about explain immediate addressing mode of 8086. So this is the way. Suppose you have 5 addressing mode or 8 addressing mode. If this question asks for 5 marks or 10 marks, all addressing modes you have to explain. But sometimes only single addressing mode can be asked for 2 marks, like flags. The seventh question is explain register indirect addressing mode of 8086. So in the sixth and seventh, only single addressing mode is asked to explain. So in this case, we have to take one or two instructions example. The eighth one is what is interrupt? List the different type of interrupts. So all these 8 questions belong to the flag register, addressing mode and interrupt. So you should prepare all these topics very well, because 2 marks question comes on only for these 3-4 topics: flag register, addressing mode and interrupts. For 4 to 10 marks in unit 4, the first question are name and explain about the different address modes used in 8086 with suitable examples. So in this case, you have to explain addressing modes for of education for 10 marks. In the last slide, you have see only single addressing mode asked for 2 marks, but here you have to explain all 8 addressing modes of 8086 for 10 marks. The second question is about explain the interrupts of 8086. So in this case, we have describe hardware interrupts and software interrupts both. The third question is about explain the pin configuration of 8086. So this is indirectly pin diagram of 8086 is asked. So you have to draw the pin diagram clearly and you have to explain the function of each pin. The fourth question is also very fixed. Explain the minimum and maximum mode operation of 8086 with need diagram. In class, I have tell you this thing. Minimum mode and maximum mode can be asked for 2 marks, 5 marks or 10 marks. If this question is asked for 2 marks, then you have to just define and differentiate between minimum and maximum mode. If this question is asked for 5 marks, then you have to make one table and you should compare the minimum mode and maximum mode. If this question asks for 10 marks, then define comparison and you have to take one diagram of interfacing to explain the minimum mode and maximum mode. In the fifth question, again this minimum mode and maximum mode question is asked. So this question repeated, man. This is important question for 8086. In the sixth question, explain the flag register of 8086 and its functions. Previously, you seen that only 1 or 2 flags asked for to explain. But in this case, we have to explain the complete flag register of 8086. The seventh one is again related to interrupt. What is interrupt and explain 8086 interrupt. So interrupt question is also repeated. Minimum mode, minimum mode and maximum mode question is also repeated. So these two are very important questions because these are repeatedly asked in your previous exam. The question number 8 is describe in detail the register organization of 8086 microprocessor. So in this case, you have to explain the register organization of 8086. So the complete register organization divided into 4 to 5 groups. So I have very well explained this topic into the class. So you can take this question from the class notes. The ninth question is with a neat sketch, explain the 8086 pin diagram and architecture. So pin diagram is repeated again. So this is also very important topic. And additionally, architecture is also asked because previously pin diagram asked for 10 marks. But in this case, pin diagram and architecture both asked for 10 marks. So this thing depend on the paper setter, how many things he asked for 10 marks. In unit 5, the remaining topics from 8086 like instruction set of 8086, assembler directives, procedures, macros, simple programs involving arithmetic, logical branch instructions, ascending, descending and block move programs, string manipulations, instructions. I have taken at least one example for all these codes from the so you can go through the class notes for this topic. And the last topic in unit 5 is overview of 8051 microcontroller. So in this 8051 also like 8085, 8086, you should know about architecture, IU ports. This thing is not available in microprocessor. In this case, we have to know about the IU ports in 8051. So in 8051, basically you have 4 IU ports and memory organization, addressing mode and instruction set of 8051 and few simple programs. But till now in examination, no simple program is asked for microprocessor or microcontrollers. So if you want, you can skip this programming topic. So in unit 5 for 2 marks, these 8 questions asked in a previous exam give an importance of the assembler directive even. So for this question, you should know about all assembler directives. So Many of the assembler directives are clear by its name. Like here, this question asks for assembler directive EBIN. So whenever EBIN assembler directive is used, your memory location synchronized to the EBIN locations only. Means if you want to save any program, then this program uses only EBIN locations of memory. So like this, for each assembler directive, you have some functioning and you have some keyboard. So you have to go through all the assembler directives. I think total 28 assembler directives is there. So I have all covered in class notes, or if class notes all are not defined, so you have to whatever defined you can go through the class notes, and other are not defined you can search for other notes or other resources to know about each assembler directive. The second question is asked for what are the flags available in 80851. So like 8085, 8086, flags can also be asked for 8051. The third one is compare procedure and macro. So this is also discussed in class. Macro and procedure both are the short programs, but procedures use written and call procedure, while macro directly used by its name in the program, and macro has very few instructions, like less than 10 instructions in this simple code and this short code, and procedure is also right for short code, but it has more than 10 instructions is there. The fourth question is list the different type of 8051 instructions. So like 8086 complete instruction set categorized into 7 or 8 category. So the same question for 8051. So you have to categorize all instructions into the groups, and you have to explain all groups like data transfer, data copy, and arithmetic and logical, like that. So fifth question is write the salient features of 8051 family of microcontrollers. So in this case, you have to write the specific feature of microcontrollers. And in this salient feature, you can explain IO ports, memories, RAM, ROM, and like architecture. So microcontroller follows Harvard architecture. So you can also write this point into this type of question. The sixth question is define indexed addressing mode. So separately indexed addressing mode and register addressing mode ask for 8051. So the question type is similar like 8085, 8086. And the eighth one is define procedure. In this case, only procedure asked, not comparison of procedure and macros. So in the eighth question, you have to define procedure only. For 4 to 10 marks, I think in fifth unit, all question asked for 10 marks because no short question is there. So like first question, give the operation of the following 8086 instruction. In this case, for 10 marks, 4 instruction is asked. ADC means add with carry, DAC decrement, MUL for multiplication, XOR for XOR operation or logical operation. So you have to explain all these 4 instructions taking a small instruction line or some example. The second question asks for explain about the different addressing mode supported by 8051 macro. In this case, all addressing modes are for 8051. The third question is explain the following assembler directives. So for 10 marks, 4 assembler directives is asked: assume, equivalent, even, and procedure. So the procedure assembler directive for write the procedure, and assume to assume the segment, and even is also discussed for 2 marks. So you have to go through all assembler directives, and collectively 4 or 5 assembler directives can be asked for 10 marks. Otherwise, it can also be asked for 2 marks. Means single assembler directive you have to define for 2 marks, and 2 may be given for 5 marks, and here 4 given for 10 marks. The question number 4 is explain about the various addressing modes supported by 8051 microcontroller. Again, the addressing mode of 8051 is ARC. So you can notice like that this is a very important question for 8051. Means addressing modes of 8051. The fifth question is what are the different instruction type of 8086? Explain all the instruction types. So in this case, you have to explain all categories of 8086 instructions. So you have total 8 categories for 8086. The sixth question is with a neat sketch, explain the architecture of 8051 microcontroller. So here architecture of 8051 is asked. The seventh question is also similar. Draw and explain the internal architecture of 8051 microcontroller. So in 8051 microcontroller, the most important addressing mode, the second one is architecture, and the third one is discuss in detail about 8051 instruction set. So in 8085, 8086, 8051, flags, addressing modes, architecture, and instruction set. These things are common and you have to know all these because nothing is there in unit 4 and unit 5 except like architecture, addressing mode, flags. All these things are common in fourth unit and fifth unit. So based on this pattern, you can prepare for your exam and all because question is asked just like a topic. So no data is there, so paper setter can change the data. If architecture asked, then you have to write the architecture. Nobody can change the answer. So practice well and score well in this exam and all the best. Thank you.